this is Honors Algebra 2 Pre-Calculus. We're doing section 6.5 in the pre-calc book, which is the trigonometric form of complex numbers. So we're going to do two examples now. We're going to do an example 3, which is sort of the opposite of what we did in example 2. And then we'll do example 4, which is really similar to example 2, but a slightly easier version, which can sometimes make it feel harder because you don't have to do all the same steps you would have to do in a traditional problem. So example 3. Z equals 8 times the quantity cosine of 3 pi over 4 plus I sine 3 pi over 4. Write this in standard form. So this is basically just applying your unit circle knowledge of what the cosine of 3 pi over 4 and the sine of 3 pi over 4 are, and then distributing the 8. So if you, if I just inch this over a little bit, so 3 pi over 4 lives right here. So all the pi over 4s are root 2 over 2s for both coordinates. It's just because I'm in quadrant 2, I'm going to have a negative x coordinate, negative root 2 over 2, and a positive y coordinate, positive root 2 over 2. So my z is going to end up being an 8 times a negative root 2 over 2 plus an 8 times a positive root 2 over 2 times this I. So when I clean up and cancel the 2's, I end up getting that my answer is negative 4 root 2 as the real component plus 4 root 2I as the imaginary component. And that's the answer, right? So it's really just about your unit circle knowledge, and that's the deal. Now, in example 4, I'm asked to take z equals negative 7i and write it in complex form. So the reason I pointed out that this is an easy problem if you sketch this and look at it with your eyeballs. But if you try to do it the traditional way, it's going to be a little confusing because your a is 0 and that's going to kind of mess up some of your stuff. Like, for instance, your tangent's going to be undefined and you're going to have to think about what that means. So if we start just by visually looking at what this would graph like, this graphs as a negative 7 on the y-axis, meaning that it has, essentially, this thing has the coordinates 0, negative 7, right? Like, that's what this thing looks like. So the short answer is, if you wanted to think this way, you could recognize that you know what this angle is. This is 3 pi over 2, and you're clearly moving 7 units in that direction. So if you can do that by visual inspection and be like, oh, I get it, the vector is 7 units long, or not a vector in this case, but the complex number is 7 units long, and I get that the angle I am clearly facing is the negative y-axis, which is 3 pi over 2, then you could jump pretty quickly from there to recognize that your z is a 7 times the cosine of 3 pi over 2 plus I sine of 3 pi over 2. And that's great. If you can do that, that's awesome. Congratulations. So if you can get there, totally cool. The other way to do it, remember we talked in the last video in example 2 about how you could actually walk backwards instead. The other way to do it is, instead of facing 3 pi over 2, you could face pi over 2 and say I'm going to walk backwards 7 units. So the other way that you'd sometimes see people write this is, instead of walking forward 7 units, walk backwards 7 units, but face pi over 2. And again, I promise you're going to get the same answer if you do it this way and clean it up. Just like we did in example 3, if you clean either of these up, you'll get this original value back. Now, if you didn't spot it in either of those directions, the other option is to physically actually walk through all the stuff and figure out what the angles are and figure out the length. So if you hadn't spotted it that way, right, the longer way to do it, that again, I don't think is worth it here, but if z is negative 7i, it's actually a 0 minus 7i, meaning your a is 0 and your b is negative 7. So when you go to find that r, you'd get the square root of 0 squared plus negative 7 squared, which unsurprisingly gives me the 7 that I got by visual inspection, right? By the same argument, I'm going to have to do the tangent of theta is the b, which is negative 7, on top of the a, which is 0, and that's undefined. And that's where I think a lot of people are going to run into an issue if they're not feeling really solid about what they're doing. So you have to think to yourself, where on the unit circle is a tangent undefined? The two places tangents are undefined are here or here, and then you would have to use your logical knowledge to pick 3 pi over 2 and get to the same spot that we were in. So again, either of those are fine. I think that this is an easier problem if you look at what it visually looks like and then work it out. But I think that this kind of problem, where there's only one of the coordinates, either a or b, and the other one is 0, can kind of throw people for a loop sometimes.